you've seen this before. This is a paired data. Okay, data comes in pair. You have a cholesterol level at the beginning and cholesterol level at the end. And the goal is to see whether the average reduction for cholesterol level is greater than 25 or not. Okay, so you know how to do a pair sample t-test, right, for this. Okay, you actually, you will record these information in your R data editor, right, and find the difference if you remember, right, and do a t-test for the difference. Okay, but this time we try to do a non-parametric test. Good non-parametric alternative for that is sign rank test. Okay, pretty much is you find the difference first. You have a sample of measurement of which is difference. And sign rank test checking whether these values are positive or negative, right? Positive, you have a plus sign, negative, you have a negative sign. And the test statistic is based on summing the data value that has positive sign or summing the data value that is of negative sign. I shouldn't say data value, rank of the data value that have positive and negative sign. Okay, and then using that to form a test. So data value like this based on rank, usually they don't need normality assumption. Okay, the rank that never be normally distributed, right? But the advantage of having rank is you don't have extreme value. Let's see how we use this so-called sign rank test, right, for study this data to test whether the reduction median, in fact, this is sign rank test. So these non-parametric tests for sign rank tests will be for testing whether the median, right, is equal to certain number or not. And when data have a symmetrical distribution, median actually and mean, they're about the same. And you use non-parametric tests, you don't need to check normality assumption because this is robust against normality. So let's see how we do this. Let's create a data, new data. I'm going to call this data set 1. Okay, I have 7 for each row, each column. Right, we have begin and after, so let's name this begin, and this is the end. All right, cholesterol level at the beginning, at the end of the period. So let's create this data. 155, 133, 15. Okay, so we have our data created, right? Subject 1, cholesterol level is 155 at the beginning and 136 at the end. So we have this pair of data from subject 1, right? Then we have a pair of data from subject 2. Right? I hope you remember. When you look at this data sheet in statistical software, each row represents data from a subject, right? So we have 7 subjects here. Okay, so have that. Now, we want to test. In fact, this thing actually allows you to test whether there's any difference between the pair, right, of data. But we already make the data, create a difference of the data, okay? So in fact, we can test whether the difference, average of a difference is greater than 25 or not, or median of the difference, right? Or that difference would be reduction if I use the first, subtract the second. So I need to create that difference. If you recall how to do that, data, manage variable and active data set, compute unit variable, and I call the result from this following computation as different. That is using begin minus n. All right, and click OK. So let's go back to this data sheet again. All right, you have the differences. And these differences is all from begin minus at the end, all right? And that amount is actual reduction. Before is 155, then is after is 136. The reduction is 19, right? That reduction is a positive number. We want to see the average of these are greater than 25 or not. That's what we want to do, okay? So let me shrink this a little bit, all right? It's greater than 25. So how do you do the test? You click statistic. It's a non-parametric test. And you can do simple, single sample Wilcoxon test, right? You click on that. And you're testing whether the difference choose the option. The difference is greater than null hypothesis. You're going to specify the null hypothesis value for the null hypothesis 25. Now these notations are incorrect, right? This should be mu less than mu 0, and this is mu greater than mu 0, and they should put mu 0 here, right? So supposedly you should use mu 0 is standard notation for the mean under null hypothesis. Okay, so we are testing whether it's greater than 25, so you could do this. Mean is greater than mu 0 means mean is greater than 25 or not if you're doing one-sided test. Okay, greater than 25. So you click OK. Then the output region section, you see the V. This is a sign test statistic, but the important thing is here, the p-value. Right. The p-value is 0.071. And we want to test this at 5% level of significance. Now this one is not less than 5%, not less than 0.05. So we fail to reject the null hypothesis. That means there's no sufficient evidence to support that the median reduction is statistically significantly greater than 25. So that will be your conclusion. Okay? Does it make sense? Right? So for testing such a hypothesis, your null hypothesis would be what? The median reduction in LDL is 25 versus median reduction in LDL is not, is greater than 25. I remember the null hypothesis always hypothesis with no difference, right? No difference means median reduction. No different from that hypothesized value, right? So median reduction is 25. And the alternative, we're reflecting this research question that is greater than 25, right? So that's very important. So it's very important that you state the hypothesis correctly. If you didn't say the hypothesis correctly, then you won't be able to draw a proper conclusion, right? So what's the p-value in this? We just saw that, right? That's what was what? 0.071 around there, right? And this number is not less than 0.05, so we're not going to reject the null hypothesis. There's no sufficient evidence for us to support that the median reduction in LDL is statistically significantly greater than 25. Okay. Any question? Okay. Now, if you look at this procedure, statistic, non-parametric, there's actually a pair sample one. So if you click on that, you can pick the first variable and second variable. And if you look at the option, they only allow you to test whether the difference is greater than 0 or not, right? So if your goal is just to see whether there's a difference between these pair, then that's good enough. But if you want to test whether the difference between these pair, right, the median of the difference is greater than something that is not 0, then this option is not going to work, right? So you got to take the approach that I just shown you for solving this problem.